Hello everybody, this is Chuck, and thanks for stopping by my shop. So you're going to see some photos of my good friend's new boat. It's a 19 mid-60s version of a Rayson Flatbottom. Got a Holman Moody Ford in it, really nice. So the other day we went to launch it for the first time, and we put just the back of the boat in the water so that we could run the motor, make sure we had water cooling the engine, everything was copacetic. Well, I saw a little drip coming off of the exhaust manifold onto the alternator, so I suggested pull the boat back up out of the water and let's investigate and see if we can tighten the exhaust manifold. Well, as he pulled it forward, we realized the boat had a lot of water in it and stood behind the boat, and you'll see the silver drain plug there in the photo, which got the red lines. Well, that thing was just peeing out water. Hence, it wasn't sealing on the back of the boat. So that's what this video is about, repairing the issue that we came across, and we didn't get to run the boat. So you've seen the back of the boat and the hole that we need to fix. So we drew up a wood template with how we wanted to create the part, and we really thought we were good, and so I 3D printed it, and I didn't really like it. I didn't like the layout of the 3 holes per our little wood block that we figured out, and I also started to figure out how it fit in the back of the boat hole and whether we were going to have a problem with it fitting. We were also making it 1.25 inch OD, which is the hole in the boat. Was really worried that that was going to be problematic. And the other thing is we were using a 1-inch boat plug. Well, here's a 1-inch boat plug, and it doesn't matter how tight you want it. It won't stay tight in there. So I went about it a second drawing, which is here, and I really like the look of it, the symmetry of it. The back piece now is not 1.25 inches, and the bore is sized for the plug. Plug's expanded there right now, but it's sized for the plug, so the plug will tighten in there. And in this one drawing, back from that drawing, you can see that we have the ability to raise it up in that bore, and then there'll be a backing piece behind here. So I have my drawing, and I've developed my layout of operations that I want to do, and I thought I'd be smart, and I colored one side of the block different than the other, try to keep bozo away, and go ahead and start doing the layout. So next up is go ahead and square the part, and then lay out the front side, lay out the back side, and then get it set up in the forejaw. So we'll bring you back after I got it all laid out. Well, I've got a piece of 1-inch plate here, so we'll get a piece out of here to start our project. Well, I don't know about using the saw. Here's what's left of my tire. I put it on high speed, and I lost the tire. Son of a buckaroo. Alright, we'll go on to another method of getting this cut. Well, I had to resort to using my jigsaw. My portaband doesn't have a coarse enough blade. Could do it on my table saw, but I'm going to go ahead and do it with the jigsaw here. Seems to be cutting well. can see the coarseness of the blade. So I got the block sawed out, and you can see my lines there. I'm way large in my lines. Just want to get the block squared up so I can relay out everything and cut the final dimensions. 1¼ inch, 2 flute, end mill. Running about 1,000 RPM. Bring you back when I got the block all squared up. Okay, I got it all laid out. Front side, which is the, where's my model? There's the front side. 3 holes in the center hole, the small hole. And then on the back side, we've got the nipple that'll stick out. And then all this stock here gets removed, so I'll end up with, you get what I'm saying, end up like that. So ready to go ahead and drill a 1/4 inch hole and use that for my centering piece on the forejaw. Just a tip, I think I bought these off of Amazon. Don't buy them for metal work. It says Metal Pro, but they really don't work on metal at all. Not like a Sharpie. It's a good tip for you. Just a in progress. No sense watching me drill on the mill, but I got the 3. I decided to put the holes in while I was in the mill. Center hole, and I've set them in for countersinks. So it just means I have an interrupted cut on the lathe on the back, which is actually good. I won't be throwing long chips at myself. So off to the lathe. Sorry for the noise. My lathe is, motor generator lathe is very loud. But I've got it in, I've got copper pads underneath it. I have access to my line that I need to cut to. I just got to be careful of these jaws, and the jaws will hit my bed if I go in too far. But got her lined up and spinning really nice for what it is. It's not a watch, that's for certain. So get a tool set up and start making some cuts. So I have emergency lights that light up the pathway so I don't trip and fall. And you may say, why in the hell do you have it on a timer? Well, it's convenient when I go from this shop to the main shop to not have to reach for the light switch. Kind of goofy, I guess. Anyway, this is working well. I'm actually going to go in and watch the 49ers play, take a little break. I got a long way to go. I got 5/8 of an inch to cut off, and I've only gone in 20 thousandths. So, got a lot of cutting to do. I don't know if it's in the frame here or not. Let me look. No. So you notice there's a red rag there. So the red rag is on the handle that feeds the lathe in. I'm feeding in manually by hand. Of course, this one is feeding across the carriage. So put the rag on there, and that way I just don't pull a bozo and grab the wrong handle, because that would be ugly very quick. Okay, we'll bring you back as we get deeper into this. I'm staying away from my mark there. I'm going to actually start staying away further and further because of the angle on this bit. I may even change this tooling so it's more straight and give it a try. But anyway, we'll bring you back. $60,000 depth of cut. Well, the interrupted cut between the edge of the block and the holes certainly makes for nice chips. But when you get down near the center, then you get all the spaghetti. We'll keep at it. Well, the hub part is complete. There's the part itself. Turns out, though, I'm about 50 thousandths fat, and about 50 thousandths fat on my 3/8 because the tool was going to hit the pads here, so I couldn't go any deeper. And then I'm going to see if I can zoom in for you there. So I dug around in my tooling and I found this left-handed boring bar that someone had ground and made out of something, and that's how I finished cutting the shaft here and finishing the facing off. So I'll have to decide. I can take that 50 thousandths off of the face if I really wanted it to be a 3/8 thick. If it's a little over 3/8, I don't think it really matters. I'll have to see when it's out of the lathe. But that portion is complete. It's the size. Next is chamfer the edge, drill the hole, chamfer the hole, and then pull it out of the lathe. Lots and lots of chips here. Okay, all the lathe work here is done. And I got it chamfered on both edges, so time to pull it out. Well, the job's finished. Started to get to a little bit of a rush, so didn't film some of the last little items. you don't need to watch me buff aluminum. Made a backing plate for it, and that'll be on the inside of the hull. But turned out nice. Real happy with it, and we will see how it functions. Going to the lake this weekend, and hopefully it all fits. It should fit, and it should stop the leak that we had. So I hope you enjoyed the video. I just got to mention, I think I did the other day again, about 3D prints. It is so nice to be able to do a prototype first with a 3D print rather than the build. Had I actually built from the wood, which was this guy here, it was going to be wrong. And the 3D print really just brings it, got it in your hand and you can see what's wrong. Anyway, I hope you guys enjoyed, and we'll catch you on a follow-up Screwy Tuesday.